Hello everyone. This video will help you to solve a problem in the cumulative distribution function, which is of a discrete random variable type. Without wasting time, we'll quickly move on into the problem and then apply the properties of CDF to solve it. The problem is a random variable capital X has the following distribution. So the capital X takes the values 0, 1, 2, 3, 4, 5, 6, 7 with the corresponding probability of X being 0, K, 2K, 2K, 3K, K square, 2K square, 7K square plus K. The question is to find the value of K. Number 2, find the probability of 1.5 less than X less than 4.5, conditional probability of X greater than 2, and number 3, find the smallest value of the lambda such that probability of X less than or equal to lambda is greater than half. We will have to keep in mind CDF is denoted by your capital F of X and it varies between 0 to 1. You define your capital F of X as probability of X till the point or the current position X, which is got by adding all the probabilities P of Xi until the point of Xi. So we will quickly find the value of K. How to find the value of K? K is involved in the probability. So we know that addition of all the probabilities is equal to 1. So this gives me 0 plus K plus 2K plus 2K plus 3K plus K square plus 2K square plus 7K square plus K equal to 1. Don't forget this 1 over here, otherwise everything will collapse. So now let us combine all the highest power of K, which is K square. 7, 8, 9, 10. So you will have 10K square. The next in order is going to be K. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you will have 9K. And how about the constant? You have 0. So 0 will be equal to 1. Take it to the opposite side. So you will have 10K square plus 9K minus 1 equal to 0. So be careful about this one. If you are missing it, then the value of K will be entirely different. This is a quadratic equation and this will have two roots. How to solve for it? So 10K square, this middle 9K, let me split in terms of 10 and 1. So it will be 10K minus 1K minus 1 equal to 0. So this will give me 10K, I take it common outside from the first two terms. So this will give me K plus 1. When I take minus 1 common outside, you will have K plus 1 equal to 0. So you will have 10K minus 1 or K plus 1 equal to 0. So now this gives me two values of K which can be obtained as 10K minus 1 equal to 0, or you can have K plus 1 equal to 0. So you will have K equal to 1 by 10, or you can have K equal to minus 1. Which you think is going to be more suitable for our problem? Okay, we will go back to the question and check where this K is appearing. So where is this K appearing? This K is appearing in the quantity called as probability. What we know about probability of any value? Probability always varies between 0 to 1. Can probability take negative values? No, never. So the value that K takes the value minus 1 is not possible, and so the only option for us left out is K takes the value 1 by 10. So now go fix your values over here for the probability, in which case what happens? X takes the value 0, 1, 2, 3, 4, 5, 6, 7, and the corresponding probability of x now becomes equal to 0. K is going to be equal to 1 by 10. This is going to be 2 by 10, 2 by 10. So this is 3 by 10. K square, so 1 by 10 square, so that makes it as 1 by 100. 2k square, so this is 2 by 100. 7k square, so it is 7 by 100 plus 10, so that makes it as 17 by 100. So we have got the probability of our distribution. Now stepping into our second subdivision. Our second subdivision requires us to find the probability of 1.5 less than x less than 4.5 condition x greater than 2. Children, we will have to recollect the formula pertaining to probability of A condition B. Probability of happening of the action A provided B has already taken place. You read this as A given B. A given B, meaning B has already taken place or have got over. Depending on it, what is the probability of the happening of A? So how to find this conditional probability? You call it as conditional probability because A is conditioned on B. So this is given by the formula A intersection B divided by P of B. So what we have is probability of A condition B is probability of A intersection B by P of B. Now fix this to the question which is given over here. Probability of A condition B. So what is going to be probability of A condition B? Now this can be rewritten as probability of 1.5 less than x less than 4.5, that is A intersection B x greater than 2 and divided by probability of B, which is going to be x greater than 2. Now our denominator seems to be so simple because it's x greater than 2. So from where to where we will have to add? 2 is included? No, we don't have an equal to. So beyond 2, what are the quantities available? 3, 4, 5, 6, 7. So it is the addition of 2 by 10, 3 by 10, 1 by 100, 2 by 100 and 17 by 100. Or you can go the other way round, like it's the same as 1 minus probability of x less than or equal to 2. So what will be the value for less than or equal to 2? 1 minus probability of x equal to 0, x equal to 1 and x equal to 2. So what you will have over here is 1 minus x equal to 0 is 0, x equal to 1 is 1 by 10, x equal to 2 is 2 by 10. So 2 plus 1 makes it as 3 by 10. 1 minus 3 by 10. So this makes it as 10 minus 3. So it is 7 by 10. So what is our denominator? We are now fixed our denominator. Denominator is 7 by 10. Now let us quickly move on to the numerator part. We have A intersection B. Let us one more time recollect what do you mean by intersection. Intersection meaning common region or common portion. Okay, so now let us have an line number which represents the numbers from say 0, 1, 2, 3, 4, 5, 6, 7. Okay, so now we will try fixing this probability in the line number 1.5. Where is our 1.5? Here. 4.5. It is here. You want it between 1.5 and 4.5. So this is going to be our 1.5 to 4.5. So this is my region number 1. Next region is x greater than 2. Which is going to be x greater than 2? Is 2 inclusive? No, 2 is not inclusive. So without including 2, I move greater than 2. It has to go and move on till the value of 7. So this is going to be greater than 2. X greater than 2. Now quickly we can visualize which is going to be the common portion for both of them. Your common region. So what are the number which is going to be both in the red rectangle as well as in the yellow rectangle, the numbers are nothing but 3 and 4. So what is happening in your numerator? Your numerator just has the number probability of x equal to 3 and probability of x equal to 4. So the problem which looked very complicated has now turned out to be very simple by visualizing it in a line number. So what is probability of x equal to 3? X equal to 3 is 2 by 10. So this is going to be 2 by 10, and probability of x equal to 4 is going to be 3 by 10. So that total makes it as 5 by 10. So what is our numerator? 5 by 10. What is our denominator? 7 by 10. So what is the answer for the final version? Numerator by denominator. So it is 5 by 10 divided by 7 by 10. So 10 can be cancelled off, leaving you with the final answer as 5 by 7. So the final answer is 5 by 7. Now let us move on to the third subdivision which we have been given for. The third subdivision has us to find the smallest value of lambda for which our probability of x less than or equal to lambda is greater than half. Now let us recollect the definition of your cumulative distribution function f of x, where we know that it is capital X less than or equal to small x. Can you identify the nature, dear? So over here what we have been given or asked is going to be our cumulative distribution function. So let us quickly fix what is going to be our cumulant. Values of x are 0, 1, 2, 3, 4, 5, 6, 7. And the corresponding probability of x are going to be, so we had it to be equal to 0. It is going to be 1 by 10, 2 by 10, 2 by 10, 3 by 10, 1 by 100. The next one was 2 by 100 and the last one was 17 by 100. Now quickly what we require is capital F of x. So let us estimate capital F of x. We notice that the first number is always already 0, so we need not have to add an extra 0, and the final value is always equal to 1. 0 plus 1 by 10 is 1 by 10. 1 by 10 plus 2 by 10 is 3 by 10. 3 plus 2 makes it as 5 by 10. 5 plus 3 makes it as 8 by 10. 8 plus 1 by 100. So it makes us as 80 plus 1. So it is going to be 81 by 100. The next one 81 plus 2, that makes it as 83 by 100. And 83 plus 17, that makes it as 100 by 100, which is going to be equal to 1. Now observe children, what we want is x less than or equal to lambda, x less than or equal to x. So in place of x, you have a lambda. Where is our x? X is our random variable. What is required? The smallest value of your lambda where this cumulant is going to cross half, greater than half, becomes more than half. Just check where the cumulant is going to cross half. Is it happening here? 0 is not greater than half. Is it happening here? 1 by 10 is not greater than half. 3 by 10? No, this is not greater than half. 5 by 10? Okay, a point to know. 5 by 10 is equal to half, but it is not greater than half. What we require is greater than half. So where is the smallest number it becomes greater than half? Yes, 8 by 10 is going to be greater than half. So this cumulant 8 by 10 is happening for which random variable? The random variable corresponding to it is going to be equal to 4. So the value of lambda where this cumulant crosses half is going to be 4. So the value for smallest lambda is x, which is going to be equal to 4. That's it children. This will fix the problem in a very easy way.